Alright, so this is confidence intervals for one sample categorical data. And for categorical variables, they are data placed into non-numerical groups. So an example would be color. And for these types of problems, we're going to be using proportions, and we'll be using z star, and all the data is one sample, so you're going to compare one group to the rest of the population. An example would be like the sampling distribution. We're using this equation, and then our variables are p hat, which is the statistic of the sample proportion, t star, which is a test statistic, and then SE is a standard error, and we'll be using this equation for that. So when we actually solve the problems, this is the equation we'll use. And then after we do state, plan, do, conclude. And for state, you have to identify the type of confidence interval, and then also say what percent confidence interval you're using, and then after provide context. For plan, get to satisfy our three conditions of random large counts condition, and then the 10% condition. And we'll be using these two equations. And then do, we use the same equation I already talked about up there. And then for conclude, we state we are blank percent confidence that the true proportion of blank, the parameter, is between blank and blank, which is a confidence interval.
Okay, so to find your z star, all you have to do is hit second and then vars or distribution. And then you'll have this that pop up. Stay on distribution, scroll down to inverted norm. And then if you're looking at a 95% confidence interval, you go 1 minus 0.95. Make sure you have that in parentheses because then you're going to divide that by 2 because of your two tails at the end of a normal distribution. And you keep your mean and standard deviation the same. Hit paste, and you have that. So disregard the negative sign and just round to 1.996, and that's the same value that you would get on your green sheet if you looked at it that way. So that's how you find the z-star score on your calculator.
What it is, guys, here I have the 2016 AP Stats FRQ number 5. I'm not going to read the question, but we're going to go over number 5, part A, and pretty much it wants you to make a 95% confidence interval and assume the conditions for inference are met. So to begin, we want to follow the state, plan, do, conclude method. So we state that it's a one sample z interval for a population proportion. Then to plan, we'd have to meet the conditions that is random, 10%, and large counts. But since the conditions for inference are already met in this problem, we don't have to worry about that. For the do, I think it's very important and a useful tip to write down the formula. So the formula for a one sample z interval is p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. And because we already wrote down the formula, I think that can save a lot of time and avoid mistakes, so we can just plug in the data they give us. So the p hat from the problem is 0.37. For z star, you look at table B and the row and column corresponding to the confidence level they gave us, which is 95%, and the infinity row. So we get a z star value of 1.96. Then we plug in the other p hat, and we do 1 minus p hat to get 0.63, and divide by n, which they told us is 1,048 adults in this problem, to give us a confidence interval from 0.34 to 0.4. Finally, we want to take the numbers that we just found and plug it into a formal statement for our conclude. And this is where people can easily lose points if they don't understand the wording and don't understand how to format it correctly. So we want to say that we are 95% confident that the population proportion of all adults in the U.S. who would have chosen the economy statement is between 0.34 and 0.4 to get maximum points. Ultimately, I believe if students write down the formula and memorize the wording for the conclusion, they will avoid losing easy points and can achieve much higher scores and maximize their points.
So some common errors that many people make. So one common error is that people do not know which equation to use. And since we are trying to find confidence intervals for categorical data one sample, we should use a one sample z-interval equation, which is p hat plus or minus c star square root p hat times 1 minus p hat divided by n. It's important that we do not use one sample t interval, two sample z interval, and two sample t interval. Another common error that many people make is that they do not know which conditions to check. Since we are finding categorical data, we are checking random, 10% condition, and large counts condition, and not checking for normal/large sample. The last common error that many people make is that they do not answer the question in context. The easiest way to solve this is to use this sentence structure. We are C% confident that the interval from blank to blank captures parameter in context. Thank you for listening.